Hey guys, welcome back to another video. Today we're going to be looking at Leetcode 240, Search a 2D Matrix 2. We've already solved the first part of this problem, which was Search a 2D Matrix, and this is a take on a more complicated version of that first problem. The problem description tells us that we're given that we need to write an efficient algorithm that searches for a value. This value is a target that's passed in to our function, to our boilerplate, and we have an m by n integer matrix. And this matrix has the following properties. Integers in each row are sorted in ascending from left to right. So that checks out, we already did that. And that was the same in the first problem. But here we can see integers in each column are also sorted. So, we can't assume that in this example, 2 would be greater than 15 and that, the last element, the first element, let's say y, is always going to be greater than x if x is the last element. That's not the case. It was in the first problem, but not in the second problem. So how would we solve a problem like this, right? So, we're given an example and we're given output is true, but that's not important. We already know how we want what the result and how this problem actually works. But how do we solve this? So first thing we can kind of think of is we solve the first problem by using binary search. Now, definitely would recommend watching this video, but I'm going to go through watching the first video, but I'll go through it anyway. So we solve the first problem by doing binary search on all the rows. And then once we find a column, we would do binary search on that column, but that won't work in this case. Instead, what we can do is say, let's look at each row, go through each row, and then do binary search. But, that's only half of the puzzle. We're kind of missing a lot of the puzzle because, we know that it's sorted not only horizontally, but also vertically, right? So we want something more optimal than just doing binary search on each row. Can we figure out a way to do binary search on the rows and the columns? So let's look at an example. We're looking for 5. We're at 1. Let's say we find the midpoint is 3 and 7, right? So midpoint is 3, then here, in the column is 7. Can we somehow extrapolate a way to find 5? Well, no, not really. There is no kind of rule which will allow us to, find the midpoints and somehow figure out we can get 5. There's no real way to do that as far as I'm aware. So the better way to do this is actually by let's think about where we want to start. Let's start in the left hand, bottom left corner, and let's say, is 18 greater than 5? Yes, it is. So we know this entire row we can just discard. Is 10 greater than 5? Again, we can just discard this entire row. Is 3 greater than 5? No, it's not. It's less than 5. So we can discard this entire column, right? We know all of this is going to be less than 5, right? So we can discard this entire column. We say, is 6 greater than 5? Well, yes, it is. So again, we discard this entire row, and now we get to 5. 5 is the target, therefore we return true. Okay, if 5 was not in the result list, we will just keep going until we get to the top right-hand corner, and then we will just return false. Okay, so that's how we're going to solve this problem. Again, doing binary search. Or actually, not even doing binary search. We won't be doing binary search actually, or kind of we will be doing binary search in a way. We will be looking at kind of like a play on binary search to solve this. So yeah, I said this is a binary search problem. So let's actually get to coding our twist on binary search to solve this problem. First thing we want to do is get the m by n. These values are just going to make it easier for us to work with this problem. So the length of the matrix and the number of columns is length of matrix 0. And we can get the row and column, row C0, 0, and then we want to take we can say m minus 1, and 0, because we want to start in the bottom left-hand corner, right? And then we want to say while row is greater than or equal to 0, so while we're not at the top and while we still have a column left, while C is less than m, let's say if the matrix RC is equal to the target, in that case we just want to return true, so let's just return true. Else if target is greater than matrix RC, in which case we want to, where do we want to look? We want to yeah, we want to shift our column, right? Otherwise, we want to just shift the row by 1. Oh, actually, yeah, we want to go up, right? And then if the while loop finishes without returning true, we're just going to return false. Let's submit our code. Let's check that works. And we get the wrong answer. Why do we get the wrong answer? Let's look through it. Is greater than, okay, target is greater than the matrix. And -1, 0 is less. Okay, so we're saying C is less than the number of rows, but this should be the number of columns, right? So let's submit the code again. And now we see that we pass all test cases for a fairly optimal solution. So in terms of time complexity, for this problem, guys, we're looking at a big O of m plus n time solution. And space complexity is obviously just going to be constant. We're not using any extra space. So with that being said, guys, I hope you enjoyed this video, and I'll catch you in the next one.